In 2017, United Airlines canceled 6 and delayed hundreds of flights, not because of weather, not because of a strike. Their systems couldn't agree on what time it was. One stored timestamps in coordinated universal time, another in local time, and chaos followed. Poor handling of temporal data isn't a small bug. It can shut down airlines, break systems, and cost millions. In this video, I'll show you how to use different temporal data types the right way in your database design, so your systems don't go off schedule. The most commonly used temporal data types include date, time, datetime, and timestamp. Date simply is a data type representing calendar dates. A data point of this type can simply be 2025 June 9th. Time as a data type represents the time of a day. A data sample of this type includes the hour, minute, and second. Datetime as another data type can be thought as the combination of date and time, because it contains both the calendar date and the time of a day, all in your local time. Timestamp is similar to datetime, but the date and time are tied to a specific time zone, like Pacific time zone or Eastern time zone. That's an overview of all the different commonly used temporal data types. Now let's look at each of them closely, starting with date. As you just saw from the overview, date is a data type representing calendar dates, just the year, month, and date without the time of a day. When should you consider using date as a data type for a column? When you only need the calendar dates instead of the time of a day. For example, think about the database of a library that loans books to people. Typically, only the information of dates are tracked by such a database and the system it supports. So date as a data type would be good enough for attributes such as checkout date and return date. That's date. The next commonly used temporal data type is time, which represents the time of a day without calendar data information. When should you consider time as a data type for an attribute? When you only need the time of a day instead of the date. For example, think about the database that supports course scheduling at a university. The start and end time of a class doesn't need to record the calendar data information. Such attributes are typically assigned a time data type. The datetime as a data type combines both the calendar date and the time of a day, and it's bound by your local time zone. When should you consider datetime as a data type for a column? When you need both date and time, but don't need to deal with the conversion of time between different time zones. For example, the database of hospitals typically use datetime as a data type for appointment time, like this. Because medical records shouldn't change based on the server time zone settings, more importantly, you might need to store very old appointments before 1970 or for future appointments. In comparison, the range of datetime is much bigger than timestamp. Datetime goes from year 1000 to one short of 10,000, whereas timestamp only goes from 1970 to 2038. Judging by the range, you might think that timestamp is much less powerful, but its power doesn't lie in the range. The power of timestamp lies in automatic time zone handling. A data point of timestamp is tied to a specific time zone or the coordinated universal time. Timestamp data can be converted from one time zone to another, which is very useful when you need to support applications used by people across the world. Speaking of that, when should you consider timestamp as a data type for a column? When you need an accurate time, and your application needs to work across different time zones or servers, then you need the help from timestamp. For example, think about the table storing the purchase records from a database that powers an online store. The store sells internationally, which means that its users come from different time zones. To make the purchase time of such users consistent, you can assign timestamp as the data type for the purchase time attribute. That's everything about timestamp data type. In this video, we covered the common temporal data types and discussed when they should be used in database design. If you find this video helpful, give it a thumb up, subscribe, and leave your questions in the comments. I would love to hear what's working for you and what needs to change. This video is based on the book Grokking Relational Database Design, which dives deeper into database design using real-world examples to explain the concepts. You'll find the link to the book in the first comment.